I would like to spend a little bit of time today talking to you about education and public outreach in the context of astronomy and space science. Now, the reason that astronomy education and public outreach is of interest to lots of people has to do with the nature of astronomy as a career. Many people think astronomy would be a fantastically exciting career to follow. The idea of going up on top of a mountaintop, looking at the stars all night long, coming home and sleeping all day long. Turns out astronomy isn't like that. Astronomy is a lot to do with computer science and not a lot of time spent behind the telescope. But still, as a career field, it's pretty darn exciting to be studying the universe and everything out there. As science professions go, astronomy is a pretty small field. There's only about 6,000 professional astronomers in the United States, about 10,000 worldwide. Because of its size, people in astronomy all kind of know each other. It's a highly collaborative group. Very rarely will you go to an astronomy meeting and not know anybody that's there. Or very rarely will you see an astronomy person on TV and not actually know who they are. And there's an advantage to that. But there's also some disadvantages to that being such a small field. One of the problems with it being such a small field is that there's not a lot of turnover. Turns out that astronomy jobs don't show up very often. About 150 jobs per year that are advertised, whether that be in universities or be in industry or a number of different places. That's on average the number of PhDs that are created is about the same number, about 125 PhDs per year. So if the same number of people become astronomers with PhDs as there are job openings, it means that sometimes people begin to look for other career paths. Now, I should point out that with retirements and with advertising of jobs, turns out that astronomy is a pretty good field to be in. You enjoy nearly a 0% unemployment rate. But that doesn't necessarily mean that everybody in there is studying astronomy. You can get a job if you have a PhD in astronomy in a number of different fields. One of the fields you can find jobs in are in the medical field. For example, every time you get an X-ray, a CAT scan, an MRI, somebody has to turn that data into images. And astronomers know exactly how to do that. Astronomers know how to take numerical data and turn it into visual data in such a way that they're able to not only work with medical fields, but also work in the financial industry. Wall Street hires lots and lots of astronomers because they know how to run numerical recipes, they know how to run projection models, they know how to use computer science to do the kinds of work that the finance industry needs. A number of astronomers also decide to become teachers. As many of you know, teaching is a fantastic field. You get a chance to work with other people, you get a chance to influence the youth, you get to share your excitement for astronomy. But some people don't think being a teacher is a very good idea. The idea of spending all day with a 12-year-old is sometimes not appealing to some people. Also, teachers don't tend to make a lot of money compared to professional astronomers. And teaching has a large turnover rate because that work is just really, really hard. Many astronomers do consider education as a career, either because it's a tight job market and they can't find a job that allows them to talk about astronomy a lot, or because they just have a real passion for working with people. Some astronomers turn to education and public outreach. And that's what I want to spend some time talking with you about, and we're going to read a lot about in the context of this course. Now, I want to point out that science education is really, really important to scientists. For one, scientists have a moral responsibility to share what they're doing with the tax-paying public. But they also have a practical responsibility, and that is that if taxpayers are paying the bill, well, then they ought to know what they're getting for it. So between that and the idea that scientists have to create other scientists in terms of the career pipeline, education public outreach is probably a pretty important idea. Now, so you might think that what scientists do then is just go out to the school's children's classroom and give presentations. Turns out, though, as I mentioned before, there are about 6,000 astronomers in the United States. If we realize that there are 15,000 school districts, there's 110,000 buildings out there. That's 2 million classrooms serving 50 million students. There's no way that 10,000 astronomers can cover all of that. So just going to classrooms and giving presentations really isn't enough. So people begin to think about, how do I find a bigger audience of people to talk to? And one strategy is to go talk to people who already love astronomy or just love learning about stuff. But I got to tell you, that's pretty easy. That's really not getting at what we're talking about when we start talking about education and public outreach. It's really very effective. Specific target audiences that people work toward in astronomy, education, public outreach are K-12 teachers and students. They're undergraduate students who are not majoring in science. Those are the business majors, the political science majors, the accounting majors. But we do also think about science majors who happen to be at minority institutions like historically black colleges and universities, Hispanic serving institutions, or minority serving institutions, and just the general public. In other words, people that already want to learn about astronomy is not the tough audience. It's these other groups who we really try to target. So in doing so, we began to try to think of the spectrum of ways that we might begin to think about and who we might begin to talk to. In general, we break up education public outreach into 3 domains. Those are domains of formal education, informal education, and public outreach. But there's still other things that have to go involved. Like there's marketing, people in astronomy that just do marketing, and there's groups of people that just do journalism or news media support. So there's an entire spectrum of places where people get involved in astronomy education and public outreach. So I want to kind of separate these things out here for you. So just so you understand what marketing is. Marketing is not teaching people about science. Marketing is teaching the world that science is very cool. And we're talking about things like posters, we're talking about things like CD-ROMs, we're talking about things like coffee mugs, things that remind people that science is very, very cool and their tax dollars should support it. It's not education, but it's still pretty important. Then there's also the group of people that do scientific journalism. Writing articles for newspapers, writing articles for magazines, doing web chats, doing podcasts. Those things are pretty important too. We usually don't think of those people as public outreach or education. But their job is not easy either. For example, when you're in scientific journalism, you're talking to people who aren't scientists, which means you can't use vocabulary, you can't use mathematics, getting your message across. So it's a really challenging thing. It's not that it's not important. It is, but it's not education and public outreach. In general, we keep education and public outreach in these 3 realms that we have here of formal education, informal education, and public outreach. So let's look at these 3 dimensions one at a time. Formal education, these are things where we're talking about where you find students in places that they are required to be, things like classrooms. Informal education are places where you find people who've gone there on purpose. They wanted to learn more about astronomy, so museums, for instance. And public outreach is where you go to where people are and they weren't expecting to see you there, when they're walking around down the sidewalk, when they're at a sporting event. Those kinds of things refer to the domains of public outreach. So let's talk about each of these individually, because it really spans the number of people that you can talk to and its trade-off, which is how much time you get to talk to them. In formal education, you can talk to people for 8 hours a day, 5 days a week. As opposed to public outreach, you may only get 90 seconds, maybe at most 3 minutes with people. So the depth of your message can't be nearly as deep in that sort of setting. So formal education. As I mentioned, but this is really classrooms, places where you have teachers, where kids are required to be. You can often have a long period of time. You can do quite a detailed assessment to find out how well things are going in there. And again, there's a lot of people we're talking about. 300 million people in the United States, 50 million of them are students. So to have access to 1/6 of the population is kind of a nice thing to have. The ways people do that in education and public outreach are often in the form of curriculum materials. Here are some materials listed here from the University of California, Berkeley's Lawrence Hall of Science, where they've made curriculum materials. But it's not always curriculum materials for use in classrooms. It could also be programs. One of the most famous is Astronomical Society of the Pacific's program called Project Astro. In Project Astro, what happens is scientists are partnered with teachers, and those scientists go visit those classrooms periodically throughout the year. And so they build a relationship with those teachers and help them out. Then, of course, there's tons of college materials that are created, and some of the work done at the University of Wyoming and at the Center for Astronomy and Physics Education is reflective of this. All right, so that's formal education. But a totally different realm is what we call informal education. Informal education is usually thought of as museums, planetariums, thought of as science centers. And this is where you have people that come to you to learn about science, maybe or maybe not coming to learn about astronomy specifically. But the big difference between formal education and informal education is choice, free choice. Students don't often have a choice to listen to you when you go to their classroom. But informal education, that's where people are choosing. But you don't get to spend nearly as much time with them. So what people have been doing, particularly NASA, have been creating these enormous exhibits, the size of a house, that can go from one museum to the next to talk about the new, interesting, exciting things that's going on in the world of museums, or going on in the world of science. This particular exhibit here, called the Space Weather Center, costs about $2.5 million to produce. All right, so that's informal education. The difference between formal education and informal education has a lot to do with how much time you have to talk to them, which means in informal education you don't often get to get as deep. But even less deep and even less amount of time, but much larger numbers, is public outreach. Public outreach is when you go out to where people are every day. Maybe they're in their car and they're listening to the radio, or they're on the treadmill and they're listening to a podcast. Maybe they're at a football game and they're looking at the Jumbotron. IMAX movies, these giant format films that you find in many movie theaters nowadays. It's a great place to do outreach about science. Radio programs like Stardate and their accompanying magazines. So I hope you can see there's really a lot of work that can be done. And scientists involved in education public outreach tend to break up into 3 different domains, what we call advocates, resources, and partners. So let's see an example of what this looks like. And this is work that was done by Sherry Morrow when she was at the Space Science Institute. So someone who's interested in working with K-12 students, an advocate would be someone who goes to the school board meeting and says, hey, science is really, really important. Where a resource would be someone who works with teachers to help run the local science fair or judge the science fair, as opposed to a partner, which would be somebody who would actually mentor a student, bring the student into their lab. On the other hand, let's think about college education for a minute. Someone who thinks that science education and astronomy education is important might speak up at faculty meetings, or they might go into classrooms and make presentations if they want to be a resource. Or if they want to be a partner, they'd actually build courses or write textbooks for these sorts of things. Then another domain is systemic change, where people need to figure out how to best be useful in that system, where we talk about the whole country together. So working at professional societies, an advocate would go to professional societies and say, hey, education's important. Somebody who is a resource, on the other hand, would take a look at things like the National Science Education Standards or the Next Generation Science Standards and review those, provide scientific content review. Or a partner might actually be involved in writing these sorts of things. So there's a wide variety of things that can be done, that need to be done, depending on how far you get into education and public outreach. And an important part of all of this is to recognize is there are some differences between who scientists are and who school teachers are. We have to be able to bridge these challenges if we want to be effective in education and public outreach. What are some of the differences between scientists and school teachers? Scientists can be jerks sometimes. They can be intellectually arrogant or overly confident. They're often critical in their speech, exhibiting skeptical questioning, which can make school teachers uncomfortable. Often scientists are very careful about how they assign credit for who's done what. K-12 world's very different. They use a different language. Teachers often won't speak with as much confidence. Teachers are often used to working with one another to create things. They are often less critical and more appreciative. And they feel often it's perfectly okay to borrow ideas from other colleagues if it makes improvements in schools and students. So you can see here there's quite a range of things that are going on in the nature of education and public outreach. But we're going to be focusing on this particular term has to do with looking at formal education and some of its resources, informal education, some of its strategies, and public outreach. I think you're going to find this is really interesting and really exciting work.